R2 is equal to 150 mm. So this length is 200. This length is 200. So two radiuses are there. One is R1 is equal to 120 mm and there is another radius R2 is equal to 150 mm. The arm length is remaining same. So this is the upper arm and this is the lower arm. The arm length in both the cases, for 120 mm radius also the arm length is 200 only, and for the 150 mm radius also the arm length is 200 only. In the derivation of the Porter governor, we have seen that this is called as the radius. In the derivation of the Porter governor, we have seen that this is called as the radius, and from the radius till the top, it is called as height of the governor. So this is called as height of the governor, and this I will name it as A. This length I will name it as A. Let us consider this angle as alpha and let us consider this angle as beta. So this angle is alpha and this angle is beta. Similarly here also I will mark this as height of the governor, that is H, and I will mark this as A. This distance as A. I will mark this angle as alpha and I will mark this angle as beta. So two cases. So this is case 1 and this is case 2. Case 1 and case 2. So there are two cases. In the case 1 the radius is different and in another case the radius is different. But the length of the upper and lower arms are remaining same in both of the cases. We don't know what is H, and here also we don't know what is H. We need to find out the value of the H. So before going for the solution of the problem, so first let us write what is given in the data. So given data I am going to write. So given data I am going to write. So what is given in the problem statement? They have given two radiuses. So that is R1 is equal to 120 mm and R2 is equal to 150 mm. So this is the first case. So R1 and R2 is 160 mm. So this is 160 mm. The next, mass of the sleeve is given in the problem statement. The mass of the sleeve, we are going to mention it as capital M and it is given as 24 kg. The mass of the sleeve is 24 kg. Then one more data is given. The mass of each ball. The mass of each ball. So these are called as the balls. These are called as the balls. The mass of these two balls are given. The mass of ball is mentioned and I will notify it as small m, and the mass of the ball is 4 kg. So with this data, first we need to find out what is the range of the speed of the governor. Then one more thing is given. Once you find out the range of the speed, then once again we need to find out the range of the speed by considering the friction at the sleeve. By considering the friction at the sleeve. So first let us find out initially, without considering the force of friction, what is the range of the speed. So let us go for the solution. So let us find out the solution for case 1 where radius is 120 mm. So case 1. So let us find out what is the value of the range of speed. So we know the equation. We know the equation for the Porter governor, which is given as omega square is equal to 1 divided by m into h into bracket mg plus or minus f divided by into bracket 1 plus k, the whole term divided by 2. So this is our equation for Porter governor, which we have already derived. So in this equation, first understand what are the data which are missing. So I will replace, as it is a case 1, I will call this as omega 1 square. So I will replace this omega by 2 pi n1 divided by 60 whole square. So I can write omega as 2 pi n divided by 60, as I am finding out for case 1. So I will mark it as omega 1, and subsequently it becomes 2 pi n1 divided by 60. So why I am writing omega as 2 pi n1 by 60 is because we need to find out the speed. The speed is mentioned as n1. So I am replacing this omega 1 with 2 pi n1 divided by 60 is equal to 1 divided by mh into bracket mg plus or minus f into bracket 1 plus k divided by 2 to bracket 1 plus k divided by 2. So if I observe this governing equation for the Porter governor, so what are the data which are missing in this equation so that I can find out the value of speed is, the small m value I know because it is given as 4 kg, but the value of h I don't know. This value of h I don't know. I can find out what is the value of h because I know this length. I know this length. I can find out the h in this case. In this case also this length is known. This length is known. I can find out what is the value of the h. So h is unknown. M is known. G is known. That is the acceleration due to gravity, 9.81 meter per second square. So capital M is given. G is given. So F means force of friction. Initially what he has given, he has not at all given any force of friction. So once you find out the range of the speed, then for the second case, by considering the force of friction, we need to find out the range of speed. So initially the force of friction is not given, so I will take it as 0. The next one comes K. So K value is also not known. So first let us find out how to find out the value of h. H is not given, K is not given. So how to find out the value of h? So h is equal to, so this length is known and this length is known. I can find out this length using the Pythagoras theorem as h is equal to 200 square minus 120 square. So if you calculate the value of h, that is 2 under root of 200 square minus 120 square. So this is going to give you the value of the h. So the final value of the h is 160 mm. The value of h is 160 mm. Then next, we know we got the value of the h. So this value of h is 160 mm. Then next comes k. So how to find out the value of k? To get the value of k, in the derivation we have seen the equation as tan beta by tan alpha. If you go through the derivation part of the Porter governor, in that I have discussed the equation for k, that is the equation for k is given by tan beta by tan alpha. So this is beta and this is alpha. So what is the equation for tan? Opposite divided by adjacent. So this is my opposite and this is my adjacent. So first we need to find out the value of a, and if you find out the value of a, you will get as 160 only. So tan beta is nothing but opposite divided by adjacent. So opposite is 120 by adjacent is 160 divided by tan alpha. Tan alpha is once again opposite divided by adjacent. So this also 120 divided by 160. So this will be 1. So the value of k is equal to 1. So this is one thing to find out the value of k. So I will tell you one more easy way to calculate the value of k. So what is that easy way is, if the arms in the problem statement he has given, each arm of a Porter governor is 200 mm long and is pivoted on the axis of the governor. If the arms of a Porter governor are directly pivoted to the axis of the governor, very, very important thing, please remember, if the arms of the governor are directly pivoted to the axis of the governor, then always the value of k will be 1 only. This is a very, very important thing, as in this case the arms, the upper arm and lower arm are directly pivoted on the axis of the governor. So without calculation also you can write the value of k as 1. In the case if the arms are not pivoted, if these arms, upper arm and lower arm, are not pivoted to this axis, in that case you can use this equation and find out the value of k. But in this case, fortunately, the upper arm and lower arm, both the arms are directly pivoted on the axis of the governor, hence the value of k will be 1. If you calculate also, you are going to get the same value only. So it means in this equation the h and k were unknowns. Now I have found out what is the value of h and what is the value of k, so that I can find out what is the value of the speed. So let us understand, or let us find out 2 pi n1 divided by 60 whole square is equal to 1 divided by mh into bracket mg plus mg plus or minus f into bracket 1 plus k whole divided by 2. So this is our governing equation. So substitute all the values, 2 into pi into n1 divided by 60 whole square. So this is equal to 1 divided by m. The value of m is given as small m, as 4 kg. H, what is the value of h? H is in terms of 160 mm. So please remember, you have to substitute it in terms of meters, because m into g, this g is 9.81 meter per second square. So this is in meter per second square, and if you substitute this h in terms of mm, the entire problem becomes wrong. So either you keep h in mm only, or convert this g in terms of mm, or keep g in terms of meter only and calculate or convert this h in terms of meters. So instead of converting this g, I will convert this h as 160 mm as in terms of meters, so which becomes 0.160 meters. So the small value of m is 4 into g is 9.81 plus capital M is 24 into g is 9.81. F is force of friction. So in this case, initially the force of friction is not at all given in the problem statement. So I will not take the force of friction. So it becomes plus or minus 0 into 1 plus k, value is 1 whole divided by 2. So now you have got all the values into the governing equation. So each and every value is substituted in the governing equation. So only unknown term is n1 square. So by calculating or by substituting all values, you can calculate the value of n1 as 228.5 rpm. So we have got the value of n1 as 228.5 rpm. So this is for case 1 when the radius is 120 mm. So now the same thing we need to calculate for case 2 also. In the same way, we need to calculate the value of n2 for case 2 also. The governing equation is going to remain same. So I will make this as omega 1 square as omega 2 square. This n1 becomes n2. n1 becomes n2. Now next thing is to calculate the value of h and k. To calculate the value of h and k. So I need to calculate the value of h and k. So first understand how to calculate h for the second case. So for case 2, so this is our value of h. So how to calculate h? H is equal to under root of 200 square minus 160 square. So you are going to get the value of h as 120 mm. So this I will call h1 and I will call this as h2. So h2 is equal to 120 mm. Now let us calculate the value of k. Let us calculate the value of k. To calculate value of k, either you can use the equation, that is tan beta by tan alpha, tan beta by tan alpha. So this is tan beta. So the equation for tan beta is opposite by adjacent. So this is 200, this is 160, means this becomes 120. So 160 divided by 120, and tan alpha is once again 160 divided by 120. So if you substitute, so you are going to get, so 160 divided by 120 divided by 160 divided by 120. So this for tan alpha, opposite by adjacent. So adjacent H2 value is 160. So 160 divided by 120 is tan alpha. Similarly, if you make, or if you use Pythagoras theorem, you can find out the value of A as 120. So 200 square, under root of 200 square minus 160 square, you are going to get the value of A as 120. And if you substitute, you are going to get the value of K as 1. So once again, you have found out the unknown terms, that is H and K. So remaining all the terms are known to you. So it is not necessary to go once again for the other things to check, because everything is already clearly got. So now use the equation 2 pi n2 divided by 60 whole square is equal to, inside the bracket, mg plus mg plus or minus f into bracket 1 plus k whole term divided by 2. So this is our governing equation. So now substitute all the values into the governing equation. 2 into pi into n2 divided by 60 whole square is equal to, m is 4, g is 9.81, sorry, this is 1 by mh. So I have tried 1 by 4 into h. The value of h is 120. So I will write 0.120. The value of m is 4 into 9.81 plus 24 into 9.81 plus or minus. The force of friction is not given, so I will take it as 0. 1 plus 1 whole term divided by 2, and if you calculate, you are going to get the value of n2 as 191.3 rpm. So you have got the value of n1, you have got the value of n2. So we know what is the value for n1. The value for n1 is 228.5 rpm. So we have got the value of n1 in case 1 and value of n2 in case 2. So now you can find out the range of the speed. So range of speed is equal to n1 minus n2. So this is equal to 228.5 minus 191.3. So you will get the range of speed as 30.6 rpm. Range of speed is 30.6 rpm. So the first case is over. The first case is over. So everything is clearly given. Use the equation omega is equal to 1 by mh into bracket mg plus or minus f divided by 2 into bracket 1 plus k. So in the entire equation there are two terms which are unknown. One is h and another one is k. So to get the value of h, use the Pythagoras theorem. 2 square minus 160 square, you are going to get the value of h. And k is known as tan beta by tan alpha. So tan is nothing but opposite by adjacent. If you substitute all the values, you are going to get the value of h and k, and then substitute all the values into the governing equation of the Porter governor. So you will arrive at the value of n1 and n2. So bigger value minus smaller value is going to give us what is the range of the speed. So the range of speed for the problem number 1 is 30.6 rpms. So this completes the problem number 1 on Porter governor. Thank you. So let us discuss the problem number 2 on Porter governor. So let us go for the problem number 2 on Porter governor. So I will go through the problem statement. Please understand. In a Porter governor, each of the four arms is 400 mm long. The upper arms are pivoted on the axis of the sleeve, whereas the lower arms are pivoted or attached to the sleeve at a distance of 45 mm from the axis of rotation. Each ball has a mass of 8 kg and the load on the sleeve is 60 kg. What will be the equilibrium speeds for the two extreme radii of 250 mm and 300 mm of rotation of the governor balls? So I am solving the problems on Porter governor and Hartnell governor from the textbook S.S. Ratan. So problem number 16.2, and now the previous problem is 16.2, page number 563, and the present problem is problem number 16.3, page number 564. So there is no any much difference between the previous problem and the present problem. The only difference, if you observe the problem statement, the only difference which you can get is, in the previous problem both the upper arms and lower arms were pivoted to the axis of the spindle. But in the present problem, the upper arm is pivoted on the axis, whereas the lower arm is not attached to the axis, but it is attached to the sleeve at a distance of 45 mm from the axis of the rotation. So that is the difference between the previous problem and this problem. So let us draw the governor, then you can get it easily, as there are two cases, case 1 and case 2. There are two cases for this also. So case 1, so I will draw the governor first. This is the axis of the governor and this is the radius of the governor. This is the mass of the ball, and the upper arm is attached to the axis and the upper arm length is 400 mm. This distance is given, that is 400 mm, and lower arm is not attached to the axis, but it is attached to the sleeve at a distance of 45 mm from the axis. At a distance of 45 mm from the axis, it is attached to the sleeve. So this length is also given, that is also 400 mm. This is also 400 mm, and this distance is given, that is 45. This distance is given, that is 45. And the radii of rotation is, there are two radii of rotation. One is 250. So this distance I will call this as h, and this distance I will call this as a, as we have done in the previous case. This angle is alpha. This angle is beta. If this angle is beta, then if I extend it and attach to the axis, this angle also becomes beta, right? So this angle is alpha, this angle is beta. The entire length is 250, this length is 45. and the radius here is R1 is 250. 250 is equal to R1. So draw it for the second case. This is the axis of the governor. This is the axis of the governor. So here I will attach a mass, and this distance is R2 is equal to 300. The upper arms are attached or pivoted to the axis, and this length is 400. And once again the lower arm is attached to the sleeve at a distance of 45 mm. So this distance is 45. So this angle I will call this as alpha. This height is nothing but the height of the governor. This distance I will call this as A. This height is H. This height is A. So this radius is 300. This length is also once again 400 only. So this angle I will call this as beta. If I extend this and attach it to the axis, then this angle also becomes beta. If this angle is beta, then this angle will also be a beta. Is it clear? So this is the problem statement, or this is what he has mentioned. The only difference between the previous problem and this problem is, in the previous problem both the upper arms and lower arms are attached to the axis of the governor, but in this case only the upper arm is attached to the axis while the lower arm is not attached to the axis. So where this is required is, it is required while calculating the value of k. We know the equation for value of k as tan beta by tan alpha, right? We know the equation for k as tan beta by tan alpha. If both the axes are directly attached to the, if both the arms are directly attached to the axis, then the value of k will be 1 only. But if any one of the arm is not attached to the axis, then we cannot take the value of k as directly 1. We need to calculate the value of tan beta, we need to calculate the value of tan alpha, then we can get the what is the value for k. So this is important in this problem to understand where the arms are attached, what are the radiuses given. We need to find out this height, we need to find out this height. For case 1 I will call this as h1, and for case 2 I will call this as h2. For case 1 I will call this as a1, and for case 2 I will call this as a2. So now let us understand how to solve this problem. The problem is very simple. Once again we need to go through the same steps whatever we have done. So whatever we have done, once again we need to find out. So first I will calculate what is the value for tan alpha in case 1. In case 1 I will find out what is the value for tan alpha. So tan alpha, how to get the value for tan alpha? Tan alpha is nothing but opposite divided by adjacent. So tan alpha is nothing but opposite divided by adjacent. So what is the value for opposite? The opposite value is 250. And what is the value for adjacent? So we don't know what is the value for adjacent. So you can use the Pythagoras theorem, under root of 400 square minus 250 square. So under root of 400 square minus 250 square. So you are going to get the value of tan alpha as 0.8. So tan alpha is over. Next, calculate the value of k. The value of k is given by tan beta divided by tan alpha, right? The value of k is tan beta divided by tan alpha. So what is the value of beta here? So what is the value of tan beta? So what is the value of tan beta? So I will extend this as a dotted line, and I will call this distance as b. I will call this distance as b, right? So tan beta is equal to b divided by a divided by tan alpha I can make. So b is known. What is the value of b? So from this point to this point it is 250, but I want only b. So I want only this much length. So it means 250 minus this, I am going to get value of B as 205 divided by A. What is the value for A? So how to get the value for A? So A1 is equal to under root of AB square. So I will call this point as B, and I will call this point as A, and I will call this point as O. Call this point as O, this point as A, and this point as B. So AB square, I want this value. So AB square minus this square, I can get the value of this. So this AB is 200 minus this value. So what is this value? 250 minus this, this is 250 minus 45 square. So what is the value of AB? The value of AB is 400 square minus 250 minus 45 is 205 square. So I will get the value of A1 as 343.4. So I will substitute here A as 343.4 divided by tan alpha is nothing but it is 0.8. Tan alpha is nothing but it is 0.8. So we have all the values, so we can use or we can find out what is the value of the K. The value of the K will be 0.746. The value of K is 0.746. The value of K is 0.746. So now I will use the equation which is we have done in case of while deriving the equation for the Porter governor as mr omega square is equal to tan alpha into bracket mg plus mg plus or minus f divided by 2 into bracket 1 plus k. Any of the equation you can use. Either you can use this equation or you can use omega square is equal to 1 by mh into bracket mg plus mg plus or minus f into bracket 1 plus k whole thing divided by 2. So any of the equation you can use, no issues. If you use this equation, then it is also correct. If you use this equation, then it is also correct. So what is the difference? I will tell you. So here you have the value of m, here you have the value of r. Omega we need to find out. Tan alpha already you have calculated. M value is known, G value is known, capital M is known, G is known, K is known, everything is known here. So by this equation also you can do, or you can use omega square is equal to 1 by mh. M value is known, h value you can find out, that is under root of 400 square minus 200 square, 250 square. You are going to get the value of h. So substitute the value of h, remaining everything is same. So in the previous problem I have used this equation. So for in this problem I will use the other equation. So if you do it by both the equations, it is correct only. So substitute the value of m. So what is the value of m here? The value of m is mass of small ball, that is 8 kg. R is first one. I am doing it for the case number 1. So 250, it is in terms of mm. So I will write it in terms of meters into omega square is equal to tan alpha. Tan alpha value is known, that is 0.8. And next m into g. So small m value is 8 into g is 9.81 plus capital M. Capital M is nothing but the mass of the sleeve. The mass of the sleeve is mentioned as 60 kgs. So 60 into 9.81 plus or minus F. The force of friction is not given. So I will take it as 0 into bracket 1 plus K. K is 0.746 and divided by 2. So this is the equation. By using this equation, you can find out the value of omega square. The value of omega square is 237. So it means you can find out the value of omega as 15.39. The value of omega is 15.39. So if you get the value of omega, you can find out the value of n using the equation omega is equal to 2 pi n divided by 60. So you know the value for omega, that is 15.39 is equal to 2 into pi into n divided by 60. So this means you are going to get the value of n1 as 159.1 rpm. So you will get the value of n1 as 159.1 rpm. So this is for case number 1. So now the same has to be repeated for case number 2 also. So let us understand how to solve for case 2. So let us start with case number 2. So where the radius is different, that is for maximum radius. So for case number 2, the radius is 300 mm, the upper arm length is 400 mm, the lower arm length is 400 mm. So I will extend from this point with the dotted line and I will join it. I will call this point as B and I will call this distance as small b. I will call this distance as small b. Is it clear? So let us go for the second case. When r is equal to 300 mm. When r is equal to 300 mm. That is the case. So for this case also, once again you need to find out the value of b, the value of tan alpha, the value of tan beta. The value of b, first we need to find out the value of tan alpha, we need to find out, then we need to find out the value of k as tan beta divided by tan alpha is equal to what? That is the question mark. So first find out the value of b. The total length is 300. From this point to this point, the horizontal distance is 300. So out of that, the lower arm is pivoted at a distance of 45 mm from the axis. So it means this length we need to find out. So this length minus this length is going to get what is the value for b. So value for b is 300 minus 45 is given to give us the what is the value for, that is b, that is nothing but 355 mm. Sorry, 255 mm. That is the value for b. The next step is to calculate the value of tan alpha. So tan alpha, so tan beta is nothing but b divided by a. So this is a divided by tan alpha. So b is known to you, that is 255. A you can find out and substitute the values, and tan alpha is already known. So by substituting all the values, you are going to get the value of k as 0.73. You are going to get the value of k as 0.73. So it means all the values are known to me. So if I use this equation, all the values are known to me. So now let us substitute all the values. The governing equation for the Porter governor is mr omega square is equal to tan alpha. Mr omega square is equal to tan alpha. Then mg plus mg plus or minus f divided by 2 into bracket 1 plus k. So this is our governing equation for the Porter governor. So in this case, all the values are known. The value of small m is 8 kgs into r. R is this one, that is R2, that is the radius of the governor, 300 mm. I will substitute in terms of meters. 0.300 into omega square is equal to tan alpha is known to me, that is 1.134 into bracket small m is 8 into g is 9.81 plus m is 60. The mass of the sleeve is given. The mass of the sleeve is 60 kg and then g is 9.81 plus or minus f, that is the force of friction, is not given. So we are not going to consider. 1 plus k is known, that is 0.73. So this term divided by 2. So all the values are known to me. If you observe the governing equation for the Porter governor, all the values are known to me. So you can find out what is the value for omega square. So omega square is equal to 200 and the value for omega square is 277.6. 277.6. So you can find out what is the value of omega, that is under root of 277.6. So you are going to get the value of omega. But our question is not over. What he has asked? He has asked us to find out the speed. So how to get the speed? So the value for omega is 16.66. The value for omega is 16.66. Under root of 277.6, we are going to get 16.66. We know the equation for omega as 2 pi n divided by 60. So in that, we know the value for omega as 16.66 is equal to 2 pi n divided by 60. So n is equal to 16.66 into 60 divided by 2 pi. So you are going to get the value of n as 159.1 rpm. 159.1 rpm. So we have got the value of, so this one you are going to get, 147.1 rpm. The value of n1 is 147.1 rpm and the value of n2 is 159.1 rpm. Still the problem is not over because he has asked us to find out the range of the speed. So we have found out only two speeds. We need to find out what is the range of the speed. So we know the value of n1 as 147.1 rpm and we know what is the value for n2, that is 159.1 rpm. So next thing is to find out the range of the speed. So range of speed is equal to, in short I will write it as range of speed as ROS, n2 minus n1. So always we have to subtract smaller one from the bigger one. So n2 is 159.1 and n1 is 147.1. So the range of speed is 12 rpm. The range of speed for the third problem is 12 rpm. So this completes the problem number 2 on Porter governor. So once again I will explain, just understand. There are two radiuses, 250 and 300 rpm, and the upper arm is pivoted on the axis of the spindle and the lower arm is not pivoted on the axis of the spindle. It is pivoted at a distance of 45 mm from the axis on the sleeve. In the first problem, both the arms, the upper arm and lower arm are pivoted to the axis. The difference in the second problem is upper arm is pivoted on the axis, but the lower arm is not pivoted on the axis. It is pivoted at a distance of 45 mm from the axis on the sleeve. So that is the difference. If both our arms are pivoted directly on the axis, then we can take the value of k as 1. When any one of the arm, either upper arm or lower arm, is not pivoted on the axis, then we cannot take the value of k as 1. We need to calculate the value of k by using the equation tan beta by tan alpha. So there are two radiuses, that is 250 and 300. So I will consider this as case 1 and I will consider this as case 2. So for both the cases, we need to find out the value of the speed. So when I found out for minimum radius of 250 mm, the speed observed was 147.1 rpm, and for the radius of 300 mm, the value of speed observed or we got is 159.1 rpm. So all the procedure or the equation to find out the speed is given. M or omega square is equal to tan alpha into bracket mg plus or minus f divided by 2 into bracket 1 plus k, or you can use the another equation, omega square is equal to 1 by mh into bracket mg plus or minus f into bracket 1 plus k whole term divided by 2. So if you use this equation, you are going to get the value of omega, then you can get the value of n. So by following the procedure, we have got two speeds, 147.1 rpm and 159.1 rpm. So finally I can find out range of speed as maximum minus minimum is going to give us range of speed, that is 159.1 minus 147 is going to give us as 12 rpm. So this completes the problem number 2, and we have done in today's class 2 problems on the Porter Governor 1, where the arms are directly pivoted to the axis in the first problem, and in the second problem the upper arm is pivoted to the axis but the lower arm is not pivoted to the axis. Thank you. This completes the today's class. Thank you.